So some posh mathematical words for you today: conjecture, proof, and we're trying to prove a conjecture or maybe disprove it. So the first thing I'm going to do is draw a little triangle with sides of length 12, 13 and 5, like that. And theta is the angle whose opposite has length 5, so this must be theta with the opposite of length 5. I don't know that it's a right-angled triangle. I have to prove that it's a right-angled triangle. So I simply see if Pythagoras' theorem applies to this triangle. 12 squared plus 5 squared is 169, which is equal to 13 squared. But to actually complete the proof, we'd need to actually make the statement that the sides satisfy Pythagoras' theorem, and so therefore the triangle must be right-angled. So now we've got to find the value of sine squared theta and cos squared theta. Sine theta is 5 over 13. So sine squared theta is 5 over 13 squared, and cos squared theta is 12 over 13 squared. So that's sorted out the first few parts of this question. Now we've got to write a conjecture about this value of the sum of sine squared x and cos squared x. Now, if we look at theta, the sum of those is 1. So the conjecture might be that the sum of cos squared x and sine squared x is always equal to 1. So I'm going to try to prove that conjecture. So now I'm going to start by drawing a sketch of any right-angled triangle in the universe this could be representative of. I'm calling the sides P, Q and R, and I'm calling one of the angles X. Then sine squared x plus cos squared x is R over Q squared plus P over Q squared, and when I combine that into a single fraction, I get this expression for sine squared x plus cos squared x. But if we look again at this triangle, we can see that because it's right-angled, Pythagoras' theorem applies. So therefore r squared plus p squared is equal to q squared. And so sine squared x plus cos squared x is q squared over q squared, which is equal to 1, which is what we said in the conjecture. So this proves the conjecture for any acute angle x. X could be any angle that we put into that triangle there. Nothing special about the angle x. So, did you use the same method as me? It's not the only way of completing this question.